How refrigerators actually work. Explained simply, a refrigerator feels like a quiet, simple machine. You put food inside, it stays cold. But what's really happening inside is not about making cold. It's about moving heat. That difference matters more than it sounds. Cold is not something a refrigerator creates. Cold is what's left behind when heat is taken away. So the real job of a refrigerator is simple in principle. It takes heat from the inside of the fridge and moves that heat to the outside of the fridge. Once you understand that idea, everything else starts to make sense. Think of your refrigerator as a heat transporter, not a cold generator. Here's where it gets interesting. Inside the walls of your fridge is a closed loop of fluid. This fluid is called a refrigerant. It's not water. It's a special chemical designed to change state easily. Sometimes it behaves like a liquid, sometimes like a gas. And that switching is the entire trick. Let's start inside the fridge. Along the inner walls and back panel runs a thin network of metal tubes. Inside those tubes, the refrigerant enters as a very cold liquid. When this liquid flows through the tubes, it starts to absorb heat. Not because it's magical, but because it wants to change form. As the refrigerant absorbs heat from the air inside the fridge, it begins to boil. Not boil like water on a stove, but boil in the sense that it turns from a liquid into a gas. And here's the key insight. When a liquid turns into a gas, it needs energy. That energy comes from heat. So the refrigerant steals heat from the air inside the fridge. As heat is removed, the air inside cools down. That's why your food stays cold. Nothing inside the fridge is actively cooling the air. The refrigerant is simply absorbing heat so it can change state. Now the refrigerant has done its job inside. It's a gas now, and it's warmer than before. So what happens next? The warm refrigerant gas is pushed out of the fridge interior and sent to the back of the appliance. This is where you'll find the compressor. The compressor is the heart of the refrigerator. It doesn't cool anything directly. Its job is pressure. The compressor squeezes the refrigerant gas hard. When you compress a gas, two things happen. Its pressure goes up, and its temperature rises. That's why the back of a fridge often feels warm. All the heat taken from inside, plus the extra heat from compression, is now concentrated in that gas. At this point, the refrigerant is hot and under high pressure. Now it needs to get rid of that heat. So the refrigerant flows through another set of coils. These coils are on the back or bottom of the fridge. They're exposed to the room air. As the hot refrigerant moves through these coils, heat flows out into your kitchen. This happens naturally. Heat always moves from hot to cooler surroundings. As the refrigerant loses heat, something important happens again. It condenses. The gas turns back into a liquid, just like steam turning back into water on a cold window. So now the heat that was once inside your fridge is floating around your kitchen instead. That's why a refrigerator slightly warms the room it's in. The heat didn't disappear. It was relocated. Now we're almost back to the start of the loop. The refrigerant is a liquid again, but it's still under high pressure. Before it can go back inside the fridge, it needs to cool down further. This is where a tiny but crucial component comes in: the expansion valve. The expansion valve is like a narrow doorway. The high-pressure liquid refrigerant is forced through it into a lower-pressure area. When pressure suddenly drops, temperature drops with it. The refrigerant comes out the other side much colder than before. Now it's ready to absorb heat again. The cold liquid flows back into the inner coils. It starts boiling again. It absorbs heat again. And the cycle continues. This loop runs constantly, turning on and off as needed, keeping the inside of your fridge at a stable temperature. Once you see it as a loop, the whole system becomes surprisingly elegant. Absorb heat, move heat, release heat, reset, over and over again. This also explains a common misconception. People often think the refrigerator blows cold air. It doesn't. It removes heat from the air that's already there. That's why opening the fridge doesn't cool your kitchen. In fact, it does the opposite. When you leave the door open, the fridge tries to remove heat from the room air. Then it dumps that heat back into the same room, plus extra heat from the compressor. So the room ends up warmer. Another misconception is that fridges cool faster when set colder. They don't. The thermostat only controls how long the system runs, not how powerful it is. Setting it colder just means the compressor runs longer before shutting off. This is also why overfilling or blocking airflow matters. Cold air itself doesn't cool food efficiently. Movement does. The fridge relies on air circulation to move heat away from food surfaces and into the coils. When airflow is blocked, the system still works, but much less efficiently. And here's a subtle detail most people never think about. Your refrigerator is constantly fighting time. Every time you open the door, warm air rushes in. That air contains heat and moisture. The moisture condenses and freezes inside, which is why freezers build frost and why fridges have defrost cycles. Those defrost cycles aren't a flaw. They're a consequence of physics. Removing heat inevitably pulls moisture out of the air. One more thing that often surprises people. The freezer doesn't use a different system. It's the same loop. The freezer is just positioned earlier in the cooling path, where the refrigerant is coldest. That's why the freezer is usually at the top or bottom, and why cold air flows downward from it. So when you zoom out, a refrigerator isn't complicated at all. It's a heat pump, a carefully controlled heat transporter. It uses electricity not to create cold, but to move heat against its natural direction, from inside to outside. That's it. Once you see that, you'll never look at a fridge the same way again. Heat goes in, heat comes out. Cold is just what remains. That's how refrigerators actually work. That's it. Did you already know this is how it works? Did something surprise you? Or would you like to know how something else works? Let me know in the comments. If you like my way of explaining, don't forget to like and subscribe. This will really help me and the channel to grow. Thanks for watching. Till next time.